Back to another video. I hope you're all doing well. In this video, we're going to be taking a look at an MCQ question from the IB Chemistry paper 1 from November 2016. Now, it has been a while since I've done an MCQ question, but I came across this question the other day, and I think it's important that we understand how to do this question, what exactly is going on in this reaction that they're asking us to deal with. So the question asks us, which monomer is used to form the polymer with the following repeating unit? So really, what does it mean? What is a monomer? What is a polymer? So a polymer is many monomers joined together. Now imagine you have a chain, right? So you have a chain of, I don't know, the letter X. So X, 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 X. So this could be considered as a polymer. Okay, this is a polymer. X is just some random, it's something, okay. This is a polymer, many X's joined together. A monomer of this would be just the single X. This is a monomer. So mono is one, right? Poly is many. So this one single unit would be a monomer. Now, in the context of the question, what exactly do they mean by this? So how does this become a polymer? So this is actually a monomer. This is one unit. This is one unit. This whole thing that they have showed you in the question is one unit. And these lines sticking out from either ends, this is the part where other monomers can attach to form a polymer. So at this end, we have another monomer. And now this chain, it goes on forever and ever and ever and ever into both directions. And that's how you get big polymers, right? And you may be familiar with one polymer. You've probably heard this name a lot of times in your life and on many environmental agency campaigns: polyethylene, polyethylene packets, polyethylene plates, polyethylene glasses, polyethylene. What is polyethylene, right? You may be asking. Well, polyethylene is nothing but many repeating units of the chemical or the substance ethene. What is ethene? Ethene is this. This is what ethene is. This is ethene. Now, polyethylene is nothing but when you break this double bond and you create two docking stations on both sides of the carbon. So now more monomers like polyethylene can come and attach themselves to either sides and make endless chains. So there is lots of application of such polymers in industry, right? In our daily lives, polymers, polyethylene, PVC, these are all polymers that we use. So really, the only thing that is happening in polymers is the breaking of a double bond, and this breaking of a double bond between two carbons creates space on both sides for other such monomers to attach and then create a polymer. Now, how do you identify a monomer? In this whole chain, if we're asking you to identify a monomer, you may be tempted to think that this is the monomer, but that is actually not the case. This is the monomer. This is the monomer. And that is because this alone doesn't form anything. This is an unstable, what do you call, substance as it is, because carbon, the central carbon over here, has one free electron. So it's not stable. This is not what is being polymerized. It's actually this that is being polymerized. So this is being polymerized, and this is then broken. In the process of polymerization, the double bond is broken, and then you create two docking stations on both carbons, because both carbons have lost the double bond, right? So they have space to accommodate something else on that side. That's basically polymerization. And remember, guys, polymerization only deals with double bonds. Polymerization is the process by which you make polymers. And this can only happen if a double bond is present in that specific substance. If a double bond is not present, you can't do it, right? It cannot be done with single bonds. It can only be done with double bonds. I'm not sure about triple bonds because I haven't learned about it yet. But as for the IB chemistry level, you only need to know that It deals with double bonds. No double bonds, no polymerization. So they've told us in the question that we have, they've given us that this is the monomer. They've told us that this is the monomer. So what is used to make the polymer form this monomer? In other words, they're asking us, how would this monomer look like in its original state? Because this is not the original state of this substance, right? This is unnatural. This doesn't happen because on both sides, carbon is not bonded to anything. But this notation, this bracket notation is the way of the question. That's how it's denoted that it's a polymer. So it actually extends on, if other polymers extend on both sides, like I showed you below. So they're asking us, how was this possible? How was this made? And like I said, in order for a polymer to be made, you need to first have a element which has a double bond, or like something to do with enes, something to do with alkenes, right? You need to have an alkene to start with, and then only can you make a polymer. And this alkene is the monomer, is considered as the monomer to make a polymer. So which alkene is responsible for this? Well, in order to find out, it's actually really, really simple. Just put a double bond here. That's it. That is it. Just put a double bond here. Not here, not here, but here. And erase these two. These two can go away. So this is our monomer, from which a polymer is formed when we break the double bond. That is it. And this reaction is called addition polymerization, by the way. To give you a solid definition, alkenes, like I said, can undergo addition polymerization, in which large number of monomer molecules like this, or like this. So this is the alkene. It is also the monomer. And when the double bond is broken, it forms like something like this, which is the monomer of the polymer, which is the bigger substance. And these guys can join together to form a chain of a polymer chain. And really, the general equation, if you want to know, for addition polymerization looks something like this. So you have C double carbon double bonded to another carbon, R. These R's are just anything could be attached over here. It doesn't matter. Literally anything can be attached over here. You can have a halogen, you can have a methyl group, or you can have a hydrogen. It doesn't matter. So R, it doesn't matter. We're only dealing with the double bond. And when this is the monomer. So when you polymerize this, it becomes like this. So it's R, 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 R. And it extends onto both sides. And this is the polymer. This notation, this bracket notation, is our way of telling you that it's a polymer, because obviously we can't draw many monomers and the full polymer. It's just not possible to draw it, right? It takes up too much space. It's a waste of time. So we come up with an easier way. We just notify it like this with brackets. And it is also important to realize, like I said earlier, that it is only the carbon double bond to another carbon, that the double bond group, that reacts when a polymerization occurs. All other groups attached to the carbon, right? Whether it's attached to this carbon or it's attached to this carbon, it doesn't matter. That doesn't change. These are unaffected. The only thing that's affected is this double bond over here. This is what's affected. Sorry. So that's it for this video. Before I forget, we have to actually find out the answer, and the answer would be A for this one, because that's the only one that matches. The others don't really make any sense. This does not make any sense. Neither does this. This is not even an alkene. And we said that an alkene, only alkenes can be polymerized. So this is automatically out. This is just wrong. This is not what our figure donates. So this is wrong, and A is the correct answer. So that's it for this video. Thank you so much for watching. I hope you've understood the concept of polymerization and what are monomers, what are polymers, and how do you deduce the monomer from a polymer. That's it from me. Take care of yourselves, and I'll see you in another video with another question. Goodbye.